All right, seems like recording has started. Okay. Um, Thank you very much, everybody, for joining us this evening. So today, this is going to be our first webinar for this year. We started it a bit late because of multiple factors and a lot of changes were going on at VMware level. But as promised and as requested by many of you, we are going to start with the most promising topic this time. And in order to get more about this particular topic, we have one of the expert with us. He's Kyle, and he's a senior technical marketing architect for VCF. So before getting to know more about this product and its roadmap, its future and scope for varieties of other, along with varieties of other product portfolio, let's quickly try to understand a little bit about Kyle himself and his day-to-day activities with VMware, and then slowly we can deep dive into this VCF product. So Kyle, over to you.
All right, thank you. And I want to thank everyone for taking the time out of their evening to join this session. I hope that what I have to present will be of some value to you. As far as introductions go, so again, my name is Kyle Gleed. I've been at VMware for about 13 and a half years now. I spent a lot of time early on working on vSphere, focused on ESXi adoption, the vSphere client, and the move away from the Windows-based vCenter to the Linux appliance. But the last 8 years, I have focused on VMware Cloud Foundation. And in my role with VMware Cloud Foundation, I particularly focus primarily on the networking aspects of Cloud Foundation and the running Kubernetes workloads on top of Cloud Foundation. There's a couple of areas that I specialize in. And as you know, the last 6 months have been pretty crazy here at VMware. We've been through a lot, and as part of this move into Broadcom and this transition to this new era of VMware by Broadcom, one of the key things is this emphasis on VMware Cloud Foundation. So I think that's what brings us here today, and I hope to be able to give you a little context of VMware Cloud Foundation, a little bit of the history. As we go through the presentation, I'll talk a little bit about how things kind of evolved, and then I'll also talk a little bit about where we're headed. Now, everything I'm going to be presenting today is based on Cloud Foundation 5.1. I don't plan to get into any roadmap or any futures, but I will give you some ideas in terms of future direction and where Broadcom is taking VMware Cloud Foundation, and I think you'll be excited to learn a little bit more about the direction we're headed. I do have the Q&A window open as well as the chat window. If you're able to unmute yourself and you want to ask some questions, feel free to do that. It looks like we're a pretty small group. If you want to type questions in, I'll try to take those questions as they come in and get through the presentation. So with that, let's go ahead and let's jump into the presentation. So we'll start with just a little bit of before we get into the technical details of what is Cloud Foundation and how do I implement it and what does it do and what's this thing called the SDC Manager, what's this thing called the Cloud Builder. Let's just kind of step back and talk about why, going back 9 years ago, VMware decided they needed to come up with this thing that we call Cloud Foundation. So 9-10 years ago, we started seeing this trend out there in the industry where customers have infrastructure, and for a long time, that infrastructure was in data centers that customers managed or self-managed data centers. And then we had this new thing called cloud pop up, and we started having customers leasing capacity from these public cloud providers. And then there's also this thing called Internet of Things and edge computing, and we started having this need to have capacity running at kind of these remote locations. And as we evolved and we went from the data center to the public cloud out to the edge, something that stood out is we were using a separate set of tools to manage each of these. If I logged into AWS, it was a whole separate set of tools and capabilities around managing that capacity, that infrastructure in that public cloud, as opposed to what I was using on-prem with my VMware, my vCenter, and the way I was doing things there. And then at the edge, it also presented another interesting use case. And so what we had is we had kind of these silos where these applications would run across these different platforms, but we were inconsistent in terms of the way we do things. So VMware, we looked at it and said, you know what, we've got something pretty special with vSphere, ESXi, vCenter. We've got wide scale adoption. We've got a lot of people who built their careers and have a lot of, their skills are based on VMware. So what if we took this VMware this VMware platform and we made it available across all of these different solutions. So whether you're running in the public cloud, whether you're running on-prem, or whether you're running at the edge, everything is going to be based on vSphere, ESXi, vCenter, and those capabilities. And so that's kind of the vision of Cloud Foundation, and that vision has been around for 10 years. Now, if you look at the way we've kind of managed things in the past, well, I got a little ahead of myself. So anyways, that's kind of the vision, is having this common, the word foundation in VMware Cloud Foundation is very key, and it's intentional. When we were coming up with the name, this product started with a name called Evo SDDC, and it was kind of like evolution of software defined data center, kind of a fancy name. But we decided, back when we released the 2.0 version, that we were going to rename it. We renamed it Cloud Foundation. And again, that term foundation was very intentional, because this is a foundation. It is a foundation that you deploy, and whether you own the infrastructure, whether it's in your data center, whether it's leased in the public cloud, or whether it's out the edge, it's the same foundation. Okay. And so with this, we're able to drive a number of things. So probably the most obvious is this idea of a transformation of the data center. So we're moving from a data center that was traditionally siloed, where you had storage teams, compute teams, network teams, security teams, and you used help desk tickets to kind of pass between these teams to get things done. And it took a long time to get things done. We moved to this idea of managing your data center as though it was a private cloud. So having this centralized console from which you could then go in and stand up workloads in an automated way using automation, and bringing that cloud operating model to the data center. So that's the private cloud transformation. And then in parallel to all of this that I'm talking about, we had this kind of rise of Kubernetes, this wide mainstream adoption of containers, and this idea of using containers to change the way we deploy applications, to change the way we provide availability, and this need to provide orchestration for large numbers of containers. And so with that, we have this evolution of the modern applications. And so as we modernize our data center to a private cloud, we're also bringing these capabilities to then host these both traditional virtual machine-based workloads, as well as these modern application workloads for things like Kubernetes and private AI. And then, of course, we have to be able to provide, just one second here. I'm sorry, I got some things on my screen. Just a second. There we go. So then we also have to be able to provide for these workloads increased level of security. And so that's where, a lot of the NSX capabilities and the idea of having distributed firewall and leveraging some of these more advanced capabilities of what we would traditionally refer to as the software defined data center. And making those just paramount. The idea that if you have infrastructure running in your data center, you have application workload running in your data center, and you set up security rules around that, so that I have some web servers, I have a database server, and I set it up so that I've got firewall rules in place to make sure that only my app servers can talk to my database servers, and vice versa. And if somebody compromises a web server, they can't get access to my database server, things like that. Well, now you move that workload. Say you decide that you want to move that workload up to the public cloud for some reason. Well, that security policy can go with it. So kind of accelerating that adoption of modern applications, but also be able to do that in a way that's secure and adopting that private cloud. So as we've done this, we've played with a number of different terms. We've talked about, we've had terms like multi-cloud and hybrid cloud and things like that. And one of the things with the move to Broadcom and the shift the strategy is still largely the same with Broadcom, if not a little bit more accelerated. But one of the things we're trying to do is clean up some of our messaging and our wording. And so really what we're talking about is building a self-managed private cloud with VMware Cloud Foundation, and be able to extend that private cloud out to infrastructure you lease, out to the edge, as well as in your data center. So that's kind of the the messaging there. Again, hopefully this is stuff that's repeat familiar to you. If you have any questions about that, in terms of this idea of this common foundation across the infrastructure you own, you lease, and as well as the data center at the edge, go ahead and put those questions in the Q&A, and I'll watch for those. So now let's shift gears and let's get a little bit more technical. So I've talked about VMware Cloud Foundation and it being this platform for hosting these modern application workloads and being something that we deploy inside of our data center. What are the building blocks that make up this platform? So this is the way we've always looked at Cloud Foundation in the past. So we have a number of different, if 6 months ago, I would have said a number of different products. And these products come together to provide this unified platform. And so you see here, many of these are going to be familiar. Of course, we got vSphere, vSAN, NSX. Those three there in the middle, those are the core building blocks. And we also refer to those as software-defined compute, software-defined storage, software-defined networking. And the vSAN is a bit tricky because when you get into Cloud Foundation, many of you may have existing investments in other types of storage, Pure Storage or Dell EMC storage or other storage platforms. You may be an NFS shop. You may be a fiber channel shop, but vSAN may not be something on your radar, but yet you come to these Cloud Foundation presentations and you always see vSAN there. We see vSAN as kind of a modern storage solution. It is enterprise class with vSAN ESA. It is something that we think is an ideal solution for the software-defined data center. But we recognize that it's not yet got mainstream adoption, that it's not the right choice for all workloads. And so we also have support for fiber channel and for NFS. So it gets a little bit tricky when doing these presentations because we talk about software-defined storage as being a key building block. We talk about a need for vSAN, but yet it's not required in all cases. You can use your existing storage investments. So just keep that in mind as I go through. If you're not a vSAN shop and you don't have vSAN in your environment, don't feel like you need to go wide-scale adoption of vSAN to adopt Cloud Foundation. You can adopt Cloud Foundation and it will work with your existing storage. And when we get into the storage section of this presentation, I'll talk about some of the caveats and what that means. But then we have, in addition to these core building blocks, the TKG is just the Tanzu Kubernetes Grid. It's just our, with vSphere 7 and above, we introduced this capability to basically convert a vSphere cluster into what we call a supervisor cluster, where we instantiate a Kubernetes control plane. And then we can now, from the vSphere, basically treat our ESXi host as worker nodes in a sense, and we can run containers directly on ESXi. And then we can also use the Kubernetes to basically deploy additional Kubernetes clusters called Tanzu Kubernetes clusters. And so that's just basically our Kubernetes story, a whole separate presentation on that, but that's basically our Kubernetes orchestration built into vSphere. And then of course, the cloud management with the ARIA suite. So we've had ARIA for a number of years, it used to be called vRealize suite, now it's now ARIA suite, but basically this is our cloud management, it's our centralized log aggregation, and it's our self-service portal through vRealize or the ARIA automation. And so those are kind of the building blocks. And like I said before, we would call those different products. But as we go forward, just think of these more as services within the software-defined data center. And as we go forward, one of the things you're going to see is a lot of shift in direction in order to make these more integrated, more streamlined. So provide a centralized authentication, identity management for authentication, centralized UI. We're moving some of the ops functionality into vSphere. We're moving some of the NSX functionality into vSphere. Now, in terms of timeline and when that's all going to happen, of course, this is getting into futures, but that's the general direction we're headed. Now, the last component on this slide that I haven't talked about yet is that SDDC Manager, and that is the crux of VMware Cloud Foundation because that's our automation component. The SDDC Manager is where we go, we log into the SDDC Manager, and this is where we're going to go to do things like add host to my private cloud. So give me a additional cloud capacity. I'm going to go into the SDDC Manager and say, hey, let's create a new workload domain, which is going to instantiate a new vCenter server instance with a vSphere cluster behind it. I can go in and say, hey, deploy additional vSphere clusters, make clusters bigger, make clusters smaller. And as I go in and I do all this automation, and as I'm deploying this infrastructure behind the scenes, NSX is part of it. NSX is built in. So as I create a new workload domain, I'm instantiating an NSX fabric. So I can go into my workload domain and I can start creating VLAN backed networks, as well as I can start creating overlay based networks. And we'll talk a little bit about that as we go forward as well. So, so while we do, and we have in the past focused on each of these individual components, I just want to reiterate that as we go forward, just keep in mind that we're moving away from this product-centric view to this idea of Cloud Foundation just being this single solution, of which each of these individual things are just going to be services that provide these different capabilities. So you'll see as we go through the presentation, instead of referring to ARIA operations, I'll call it VCF operations or VCF automation or VCF logs or VCF networking. And so we're trying to move away from this view of a siloed type approach to more of a common foundation, more similar to what you would see like in a public cloud. If you go out to like your public cloud provider like AWS or Google or Azure, they all have similar capabilities, similar things that they do. But they're not seen as separate products. They're seen as just a unified cloud solution, and that's the direction we're moving. So in terms of how we deploy Cloud Foundation, so a couple of things to keep in mind is Cloud Foundation is a pre-architected solution. What does that mean? So it's prescriptive. We've basically come up with a standardized way for deploying the software-defined data center. That's not to say that it's not flexible. You can deploy with, you can choose your host, your vendor of choice, whether you want to do the Dell, Lenovo, or whatever your hardware platform choice is, HP or whoever. You can choose your hardware. You can even choose your configurations. Are they going to have DPUs? Are they going to have GPUs? Are you going to be using this as part of private AI? How many NICs are they going to have? Are you going to have 2 VDSs, 4 VDSs, 6 VDSs? So there is a lot of flexibility. However, at the end of the day, it is prescriptive in the sense that we have kind of a standardized way that we are going to stand up and instantiate the private cloud. We're going to start with something called a management domain. And on that management domain, we're going to instantiate the SDDC manager, which is going to be the automation component. And then from there, we're going to go out and we're going to branch out by creating additional workload domains, and behind those workload domains, creating vSphere clusters. So it's kind of a pre-architecture solution. You may have heard the term VMware validated design. That was our, documentation that kind of covered the whole architecture. We now shifted to the VMware validated solutions, where instead of focusing on the overall design, we now focus on individual solutions. So if you want to run the NSX Advanced Load Balancer on top of Cloud Foundation, we have a VMware validated solution that will tell you how you can do that. If you want to run VCF automation or VCF operations, we have validated solutions that will talk to that. Okay, so we do maintain that hardware flexibility. We do have this prescriptive yet highly scalable architecture, and that has a number of benefits. It provides consistency. It ensures success. You don't have to bring in professional services and have them design a private cloud, because the design work's already done. You can bring in professional services and just get right into the implementation. And when you call support and you tell support, hey, I'm running Cloud Foundation, they already know what your environment looks like. They may not know the details of how big it is or how you've scaled out, but they know there's going to be a management domain. They know there's going to be an SDDC manager. They know where the vCenter servers are going to be located. They know how to get the logs for this environment. So when you call support with a problem, it's going to expedite that. And so as we get in, when we talk about the architecture, we have a number of different deployment options. So if you're a smaller shop and you just have one site, 4 nodes is the minimum number of servers required to deploy Cloud Foundation. Okay, in that single site, you're going to go in and you're going to create workload domains. The first workload domain is going to be the management domain. And then it has a kind of a special purpose in terms of that's where all the infrastructure components like the vCenter servers, the NSX managers, the SDDC manager are going to run is in that management domain. Now, you can also run compute workloads on that management domain in something we call a consolidated deployment. Or you can go out and add additional hosts to your environment. So if you have maybe 12 hosts, you can go and start creating additional workload domains. So that single site deployment is by far the most common. And it is something that, again, you can start very small with 4 nodes and you can scale out to, whatever the Cloud Foundation configuration maximums are. You can have up to 25 workload domains in Cloud Foundation 5.1. Okay. In addition to the single site deployment, we also have support for running stretch clusters. So a lot of customers, they have 2 data centers that are relatively close proximity. And because for a high availability, disaster recovery, if one building was to have some type of a power outage or a fire or some type of disaster that takes it out, they want to be able to have capacity running at a second facility, and we use stretch clusters for that. So we can, when we do have support for stretch clusters. And then in addition, we also have support for remote sites. Now, remote sites are something you want to be aware of because there are some significant limitations around remote sites. This is something we are working to address. But for the most part, you're limited to the number of remote sites. You can have up to 8 remote sites, and each remote site can have up to 1 cluster. Now, that's not going to scale for a lot of the edge use cases, and that is something that we recognize as a limitation. So stay tuned. Watch the release notes for updates and changes in this. But we do have support for remote sites. And again, the remote sites are different from stretch clusters in that remote sites are when the second site is going to be located a relatively large distance away. So it's too far to do like a stretched fiber or some type of a vSAN stretch cluster. And so you need to use vSphere replication. Or I'm sorry, that's next slide. So this is where basically you're going to have a cluster. So think of a retail store that has maybe a central location where they have the management cluster. Then they have 4 or 5 remote stores, and they want to put a small set of capacity at each of these remote stores so they can basically collect sales information and things. And then, but you still want to push updates and essentially manage those from the primary site. So that's the remote cluster. Now, I got ahead of myself and I was talking about the multi-region deployment, and this is where vSphere replication comes in. This is where you would have 2 separate data centers located relatively far distance apart, and you'd go and use something like vSphere replication in order together with Site Recovery Manager in order to provide like a high availability disaster recovery type topology. And you can also run NSX Federation across this as well if you're running NSX. So as you can see, we have a number of different architectures. We can start from 4 nodes in a single site. You can go to stretch cluster. You can go to dual region, and we can also have support for remote clusters. Okay, so how do I deploy Cloud Foundation? How do I get started? So one of the first things that I think customers get a little confused is you'll buy Cloud Foundation, you'll talk to your sales team, say, okay, I'm going to buy Cloud Foundation. They've talked to you a lot about this component called the SDDC Manager. And they say, okay, I'm ready to deploy. I've got my 4, let's call it HCI, vSAN ready nodes ready. I've got my networking set up. I'm ready to deploy Cloud Foundation. And then they'll come and say, okay, go out and get the Cloud Builder. And you're like, whoa, what's the Cloud Builder? Where does this Cloud Builder come from? So let's talk a little bit about the Cloud Builder and its role. So as I mentioned, it is a prescriptive architecture, meaning that we have certain requirements. So you're going to need to have at least 4 vSAN ready nodes. Now, I talked a little bit earlier about vSAN. vSAN is required for the first 4 servers. So if you have different storage topologies, you will need to introduce vSAN for these first 4 servers. This is going to be our management domain, the first cluster I management domain, and those first 4 servers do need to be the vSAN ready nodes. So you need 4 of those. The reason for 4 as opposed to 2 or 3 is redundancy and resiliency. So we're anticipating that you're deploying Cloud Foundation because you want a private cloud, and as such, high availability is paramount. And you want to have enough capacity so that you can put host into maintenance mode, take host out of maintenance mode, survive a host failure without going into a degraded state. So we have 3. 3 is the minimum number required and 1 extra. So that's where the number 4 comes from. These 4 servers need to be connected via L2 networking, and you need to have, there's some networking requirements in terms of having jumbo frames enabled, having, there's a number of VLANs that we're going to require. There's 5 VLANs to get started, 7 VLANs if you want to run NSX edging, but those are some details that are probably a little bit beyond the scope of what we're talking about here. But you'll want to have that networking. So you want to have your host connected to the network, and you're going to want to have your VLANs assigned with your subnets and IP ranges and things like that. Okay, then you're going to go out and you're going to get this thing called the Cloud Builder. If you go out to VMware Customer Connect and you go to Cloud Foundation and you go to download, you're going to see there's really only 2 components that you download. One of them is called the Cloud Builder. It's an OVA, and it's about 22 gig in size, so it's pretty big. And then there's a deployment parameter guide, okay? And that's what this checklist represents, okay? And this deployment parameter guide is an Excel spreadsheet. And essentially what this Excel spreadsheet is every customer is going to be different. Every customer is going to have separate set of VLANs, a separate set of IPs, separate DNS, separate NTP. They're going to have a separate naming convention. They're going to want to name their vCenter servers different, then their NSX servers different. And so how do we take all this customer site specific information and capture that? And that's the purpose of the spreadsheet. So you're going to go into the spreadsheet, you're going to provide those details, and you're going to fill that out. And the spreadsheet has some error checking. It will help guide you through the process. There's a number of tabs at the bottom. But you take that spreadsheet, you download it, you send it, well, you send it off, you download it, you fill it out, and then you download that cloud builder. And then what you need to do is the cloud builder is just an OVA. It can run on your laptop as part of like VMware Workstation. It can run on an ESXi host in your data center. You just need to have network connectivity to those 4 vSAN ready nodes. Okay, so you're going to deploy it. You're going to deploy the cloud builder. You're going to take that Excel spreadsheet. You're going to import it into the cloud builder. And then the cloud builder is going to say, okay, I see the 4 servers. I see your custom specifications in terms of VLANs, networks to use, naming conventions to use, DNS, NTP. So now I'm just going to go to these 4 servers and I'm going to deploy the management domain. I'm basically going to instantiate a vCenter server. I'm going to create a vSphere cluster using this 4 host. I'm going to create, a vSAN data store, and I'm going to deploy an NSX fabric, and I'm basically going to set up, instantiate what we would call the private cloud. I'm going to instantiate this, and as part of this, we deploy the SDDC manager. Okay, so now we have the SDDC manager. And so now we can go in and use that SDC manager to start carving out these things called workload domains. And a workload domain is just going to be an allocation of capacity. So we start by adding additional capacity. So we start with 4 hosts, but let's say I'm running and I want to have maybe 64 hosts in my, my private cloud, or I want to have 128 hosts in my private cloud. Whatever that number is, you have to add these hosts into the cloud, and that's done through a process called host commissioning. So we go in, we take these free ESXi hosts, and we basically go through a process of commissioning them and adding them to the Cloud Foundation inventory. And that inventory then represents a free pool. Now, when you add these hosts can be configured for vSAN, they can be configured for NFS, they can be configured for fiber channel. One noted limitation that we have is we don't yet support iSCSI. So if you're iSCSI, just be aware that that's not yet supported with Cloud Foundation. You will see references to iSCSI in the UI and in the documentation. Just keep in mind that those in 5.1, those references to iSCSI are tied primarily to our support through vVols. So vSAN, vVols, NFS, fiber channel are the types of storage that are supported today. But if you think of the private cloud, you think of any cloud as being this pool of capacity that you can then go in and through some type of automation allocate that capacity. These servers that you add to your Cloud Foundation inventory represent that pool of capacity. Okay, quick time check here. I'm not seeing any questions in the Q&A. Again, if you have any, just throw those in there. I'm happy to take those. But once you've got that pool of capacity down there, we can now go out and create workload domains. So a workload domain is just a fancy name, fancy way of calling out a new vCenter server instance with an associated vSphere cluster. So you see here, this is our management domain represented here. You see we have our SDDC manager, our vCenter server. We have our NSX managers, our edge clusters are running in here as well. And if I want to go out and create a workload domain, what we'll do is we'll go out and using those hosts in the free pool, we'll pull those in. And what we do is, so now we have the inventory, we take the host, we add them into a cluster, a workload domain with its own vCenter server and its own NSX manager. So you'll see each workload domain is going to have a dedicated vCenter server and its own NSX fabric. And again, you can have up to 25 workload domains. Behind each vCenter server, you can have up to vSphere maximums in terms of number of clusters. So the way we scale out is, while you can only have 25 vCenter servers, you can have, large numbers of clusters behind those. And for many of us, managing vCenter server sprawl is something we've had to deal with in the past. So we don't want to propagate too many vCenter servers. So that 25 may sound like a limit, but in reality, it's not really a limit. By default, the vCenter servers will be deployed in enhanced link mode, meaning that as you deploy, say, 3 or 4 workload domains, you log into your vSphere client, you'll have centralized management of all those workload domains by default. However, you can also do what's called an isolated workload domain. Isolated workload domain basically says I'm going to create a separate SSO for that. So that's kind of the workload domains, and I want to make sure I have time to get into some of the details around storage and networking. So I'm going to go through this a little bit quicker. But once you create a new workload domain, so here we got two workload domains represented by vCenter 1, vCenter 2, and they're part of separate NSX fabrics. But now I want to go in and I want to expand out by creating a new cluster. So again, we use the SDDC manager to pull in hosts from our free pool in order to instantiate another cluster. If I want to go in and make a cluster bigger, I can also do that as well. So the idea here is you're going to start off and you're going to have this management domain, which is going to be these first 4 hosts. You're going to have this inventory of capacity that's available. This capacity is represented by additional hosts you've added to the Cloud Foundation inventory. And then as your customers come to you and say, hey, I need a place to run, say, Kubernetes, or I need a place to run a new application, or I need capacity. You go into this thing called the SDDC manager, you pull host out of the inventory, and you basically create these workload domains. And these workload domains can be for whatever use cases you want. Then once you create those workload domains, you can use the SDDC manager to go in and to scale up, scale out, and to do this. So much like a public cloud, you're going to have this ability to scale up, scale out, and deploy and allocate this infrastructure as needed. If I delete one of these workload domains, I can take those hosts, put them back in the free pool, and I can repurpose those as well. So very easy to stand up temporary pools of capacity, temporary workload domains, or temporary clusters. And then when those are no longer needed, reclaim that capacity. And you can use tools like the ARIA operations or the VCF operations to basically go in and identify things that are oversubscribed and be able to reclaim capacity. And then you can identify things that are undersubscribed and reallocate capacity. So a couple of questions, got a question here. So keyless isn't an option today. Now, one thing I'll just kind of preface here, I'm not much on pricing and packaging and licensing. That's not an area I specialize in. But with the shift over to Broadcom, we have VMware by Broadcom, we have end of life or terminated all of the subscription-based VCF Plus, vSphere Plus. That's all gone. So the keyless licensing is no longer an option going forward. You will need to have perpetual keys. Those perpetual keys are bought through a subscription. So we do have keys. Keys are required. The keyless approach, where we had basically you deploy a cloud gateway, and that cloud gateway would basically you connect the cloud gateway and manage everything from there. That's no longer an option. That's been kind of end of life, I guess, done away with. So yeah, keyless is no longer an option today. VCF Plus is no longer there. Another question is it possible to have a single node SDDC for POC and plan on production deployments for? The answer is yes. We have a couple of different ways you can do it. We do have the ability to basically take a single ESXi host with sufficient amount of CPU, memory, and storage, and to instantiate what we call a nested VCF lab, or basically we use nested virtualization in order to instantiate VCF. If I just take a minute over here, I'll show you, this is an example. So this is a nested VCF instance. You'll see this nested VCF instance has 8 hosts. And it's I've got my SDDC manager, my vCenter server, my NSX manager. I also have my ARIA LCM, ARIA Ops with Workspace ONE. I have an NSX Edge cluster. This is all running on top of a single ESXi host. And if I come over here and if I go, I'll connect to that ESXi host, and I'll show you what that ESXi host looks like. Keep in mind, this is not supported for production. However, this is something that we can do for hands-on training, for proof of concept, and it is a fully functional VCF instance. As you see, it can scale quite large, but I have a single ESXi host here. And again, how much and how successful you can be with this nesting is going to depend on the size of the host. It's not trivial. You see here, if I look at this host, you can see how much CPU, memory, and storage I have. But if you go in, you'll see that I use this convention of hollow. Hollow stands for holodeck. And so I have a hollow A instance, which we were just looking at. Those are those 8 servers. This is just all running on a single ESXi host. These are nested ESXi hosts. And inside this environment, I have instantiated VCF Lab. And if I come over here, I can show you that I have a second environment called HoloB running on this same ESXi host. So yes, you can run vSphere on a single host. Looks like somebody just posted the link there to our resources on core.vmware.com. Where you can get more information on this. But yes, the idea of nesting on a single host is great. This is how we do all of our internal stuff in terms of enablement, training, demos, and stuff. All my access is all done through that. So good question. So thank you very much. Thank you for sharing that link. And I do have a slide on that towards the end if we have time to get to it. So we've talked about workload domains. We talked about how we can basically, create them, scale them up, scale them out. And you'll see here, I'm just adding additional clusters. And again, this is something that we can work with stretch clusters, we can work with remote clusters. And if you go out to the, if you lease capacity from AWS or Google or Azure and you want to run VMware on, it's the same set of tools, same infrastructure, same capability, same architecture. Okay. This is just kind of a note to the SDDC manager. So one of the things that we've been working on a lot in the recent years is the idea of being able to scale out the SDDC, have multiple tenants all consuming the same private cloud. In order to do this, you have to be able to support parallel operations. So with the SDDC manager, we've done that. And so we have the ability to go in, for example, here you'll see I have my management domain here, and I have actually two management domains. So this would be a dual region deployment. And you'll see primary cluster 1. I have my inventory down here. And so you see I can go in here and I can basically go in and say, hey, pull hosts from my inventory and create additional workload domains. And those can all be running in parallel. I can have 2 add workload domain operations running. I can go in and I can add a cluster to an existing workload domain. I can add another cluster. I can go in and shrink a cluster and pull a host out and put it into the, back into the free pool. I can add capacity. I can, it's basically just showing how the SDC manager is this orchestration component, and we can support multiple tenants and parallel operations going. And as you read in the release notes, you'll see with each new release, we're adding additional capabilities around this. Sometimes there are some operations that will lock the SDC manager. So you'll be trying to go in, like for example, if you go in and start doing password operations, it will lock the SDC manager, meaning it won't let any other workflows running until that password operation is done. And that's kind of, because concurrent operations stuff, some things we have to manage. But we are getting better and better at supporting these parallel operations over time. Okay. So in terms of authentication, identity management, so we do use vCenter SSO for identity management within the SDDC, within Cloud Foundation. And by default, as I mentioned, when you deploy these magic domains, we are going to set up an SSO ring, so enhanced link mode. But we do have the ability to create workload domains that are isolated as well, that are not part of this ring as well. But just keep that in mind that we do have support for enhanced link mode. And so the vSphere configuration maximums of 15 workload domains in enhanced link mode. So if you go above 15, you'd have to start going to isolated workload domains. But the point being that when you log in to the SDDC manager, when you log into the vCenter, we're using vCenter SSO. So if you want to use your Active Directory credentials to log in, you'll need to add Active Directory as an identity source within vCenter server, and then you can basically use those Active Directory credentials to log into the SDDC manager, for example. And then again, you have that 15 workload limit with regards to the SSO ring. So if you go above 15 workload domains, you'll need to go to isolated workload domains. That's one of the things you'll want to think about and architect as you plan out and deploy. I talked about prescriptive yet flexible. This idea of do you want to have a single SSO ring? Do you want to have multiple SSO instances to provide some level of isolation? Those are some things you'll think about. So there's a question here, how does composable hardware infrastructure complement VCF? We've looked at composability in the past, primarily with HP and some other vendors as far as our offerings. And we actually used to have some integration in the SDC Manager where we could interface using the Redfish API. We've taken that out. What we found is that really the composability is kind of done separately. You compose the servers, you create the servers, you add the servers to the Cloud Foundation inventory. So they're kind of independent. They can work together, and you can use composable infrastructure. But VCF, we're going to consume the servers that are created as part of that composable infrastructure, and so we don't really integrate. We don't have that integration anymore in terms of the SDC manager and that Redfish API, but they can work together very well. And so I talked a little bit about the SSO ring. So you can have shared SSO instances with up to 14 workload domains plus the managed domain, so up to 15. But again, this is just showing how when you go above that, you can have isolated workload domains. Each isolated workload domain will have a separate SSO instance. So you wouldn't have that single pane of glass. You'd have to have separate login credentials for each. And you can kind of mix these, so you can have a managed domain with 20. But the point is, you can have up to 25 workload domains in whatever configuration. Some in enhanced link mode, some isolated. Just kind of showing that. Okay. In terms of identity federation, so we do have support for Active Directory. We've added support for Okta as well as over LDAP and Active Directory Federation services. So we are kind of expanding. One of the areas that we're focused on that I'm excited about is we are looking to kind of provide a common identity provider across all the different components that make up the SDDC. So that's a ways out, something we're working toward, but you can see we're making some steps here. Okay, just looking at the Q&A here. So a question about, hey, maybe this deep dive might be a little bit too much. Is there any place you can go to get some information for somebody who's more inexperienced or relatively new to this? There are other presentations out there. If you go to our YouTube channel, if the VMUG leaders would like to put together more of a basic introduction to VCF, I'm happy to come back and do that as well. I do realize that jumping into these deep dives, it can be a bit intimidating for somebody who's an experienced vSphere person, but new to this whole concept of the SDDC. It can be a bit much. So hopefully that will be helpful. So 24 is the maximum number of VI workload domains, and then you have addition of the management domain. That's where the 25 number comes from. So I haven't really talked about that VI workload domain, but remember that first cluster is referred to as the management cluster, and then every other workload, I'm sorry, I'm using cluster word, I should be using the management workload domain. The first workload domain you create is the management workload domain. And then once you create additional workload domains, we call those virtual infrastructure workload domains or VI domains. You'll see that in the documentation. So you're always going to have one management domain. Again, that's part of that prescriptive architecture. That's that first 4. That's always going to be vSAN based. And then you have your VI workload domains up to 24. That's where that 25 number comes in. Of the 25, you can have up to 15 running in enhanced link mode. And again, that's the management domain plus 14 VI workload domains. So so just some clarification there. Thanks for that clarification in the chat there. Okay, let's keep going on. I think the next story is, so we're going to get into security. This is just, I'm going to go through this. Okay, networking. So networking is one of the areas that I find I myself am new to networking. I would consider myself, even now, after 8 years of working with Cloud Foundation, still a bit of a networking novice, even though this is an area that I've specialized in terms of Cloud Foundation. My background is server virtualization. It's Linux, it's compute, it's servers. I really haven't spent a lot of time in my career focused on the hardcore aspects of networking. And so when I first got into Cloud Foundation, this was one of the more challenging areas for me. And I suspect that others could be in the same boat. We've long been vSphere admins. We've got VCPs. We've got our certifications. We know how to deploy vSphere. But when we start getting the networking world, it's a little bit gray to us. So we know things like VDSs and VSSs, virtual distributed switches, virtual standard switches, DV port groups, and how that all ties in. But now we're layering in this concept of NSX and overlay networkings. So this is an area that may take some time. There's a learning curve, but once you get through it, it's pretty straightforward. So let's, we're getting close to, we got about 12 minutes left, and I want to get through this and the storage in the next few minutes. So hopefully I won't go through this too fast. But when you deploy Cloud Foundation, remember I talked early on, I mentioned that there's like 5 VLANs that are required. So in that management domain, we take those first 4 hosts represented by ESXi 1, 2, 3, and 4. We're going to create a virtual distributed switch. And on that virtual distributed switch, we're going to create a number of port groups, DV port groups. So we're going to have the vSAN, a VLAN for vSAN, a VLAN for vMotion, a VLAN for my management host, my ESXi host, and another VLAN for the VMs, like my vCenter server, NSX manager. And again, these are VLANs that will need to be plumbed in the physical network. So we'll need to go to our physical network, talk to the networking team and say, hey guys, can you give me some VLANs here, and I need 5 of them. So we got the 4 up here that we've already talked about. Where's the 5th one? Well, the 5th one comes in with NSX, and we're going to talk about that a little bit further because each of these ESXi hosts are going to be talking on a what's called a tunnel endpoint or a TEP network. So keep that in mind. 5 VLANs to get started. We're talking about 4 right now, but you'll see the vCenter server, SDC manager, NSX manager attached to that. VLAN, and then the host attached to the others, and of course the vSAN and the vMotion are probably self-explanatory. So that's what gets created by the automation for us when we stand up Cloud Foundation. Okay, now here's where that host TEP network comes in, because in addition, now that we have NSX and NSX is part of this, we're going to create an overlay transport VLAN. So we're going to need another VLAN for our overlay traffic. On this VLAN, we need to make sure we have jumbo frames enabled. The minimum MTU is like 1700, but we always recommend you just go jumbo frames 9000. And so what that is going to do is that's going to allow all these hosts to talk on this overlay network, and that way you can do these software-defined networks inside of NSX. Okay, and again, NSX is required in the sense that when you stand up Cloud Foundation, you will need to have these TEP networks. You will need to have the VLAN dedicated with the correct MTU. So even if you choose not to go in and use segments, you still want to use VLAN backed networks. This is something that will still need to be set up as part of the deployment. Okay, then we go inside of NSX, and this is where we can create these logical networks called segments here. But these logical networks, and that's how they talk. So basically, I can go in and create 192.168.10.1 network, a 192.168.20 network, a 192.168.30 network, and I can basically define those as virtual networks inside of my NSX, and then they would run over this overlay networking, and there would be no additional configuration needed on the physical VLAN. Okay. So in terms of what that looks like from a little bit more detail, so if you go down each host, by default, 2 NICs are required. We do recommend they be 25 gigabit plus, but you can have 4 NICs, you can have 6 NICs, and we'll talk about that. But there's different topologies, again, the flexibility there. But by default, we're gonna have 2 NICs. Those 2 NICs are going to be added to the VDS, and then we're going to take all these port groups that we're creating, these DV port groups, and we're basically just going to pass those through the VDS. So all traffic would go over these 2 NICs kind of in a aggregated form. Okay. So when you IP address manager for this, so there's a concept of network pools inside of Cloud Foundation. If I come back over here to my lab environment, I'll just kind of show you there's this idea of network settings, and there's a network pool. If I come in here, I can show you that this is where we go in and we basically say, hey, for my vMotion network, my vSAN network, these are the VLANs, these are the IP address ranges, and these are what you're going to be able to use as far as IP address management. So we are going to have the SDC manager managing IP addresses for the vSAN and the VLAN. For those host TEP networks, you can use either DHCP or an NSX pool. And then for the host manager and the VM manager, you're going to manually assign those. So as far as IP address management, network pools tie in with that. And again, that's done from the SDDC manager. And then you can see here your vCenter server, NSX managers, and your SDC manager are going to connect to here using IPs you assign. And that's kind of the under the covers what the default network topology looks like from a vSphere VDS standpoint. Okay. Now I talked about the default configuration being the 2 PNICs. So here you'll see I got 2 PNICs, my VDS. So over here on the left is what we just talked about, the default profile. But you do have the ability to have custom profiles where here you can have multiple VDSs. In this example, we have 3 VDSs with 2 NICs going to VDS1, 2 NICs going to VDS2, 2 NICs going to VDS3. And what they're doing here is they're separating the overlay traffic over a separate set of physical NICs, a separate network, a physical network from, say, their manager traffic and their vSAN traffic or whatever. So basically, if you have a requirement that you separate storage traffic from manage your traffic, or you want to separate your overlay traffic, you can do this. So this works well, especially if you have older configurations like with less than 25 gigabit NICs, you can use this. So this is supported, just showing some of the flexibility there. In the UI, this is just showing an example. When you go in, you can either select that default profile, or you can go in and create a custom profile. Okay. So with NSX, there is a concept of an NSX edge cluster. So if you think about it within the private cloud, within the SDDC, one of the key design considerations that you want to think about is how many doors do I have into my private cloud, and how many doors do I have out? So ideally, if you want to secure your private cloud, you're going to have a single on-ramp, a single off-ramp, a single door in, and a single door out. And the way we can do this with a private cloud is by instantiating these things called NSX edge clusters. And so this is just kind of showing that down here we have our software-defined network. You'll remember that diagram where we had those tunnels. And it's showing how all traffic is being routed through this idea of an edge cluster. So this edge cluster is configured with a couple of uplinks that are physical connections up to our top-of-rack switches, but all traffic going north-south from our workload domains are going to go through this edge cluster. Edge clusters aren't required. You can deploy Cloud Foundation, get everything up and running, and you can just use your VLANs and go out through your normal physical network. But edge clusters, as you get more into it and you start looking at software-defined networking, you start looking at providing gateway firewalling services through NSX and providing that single on-ramp, off-ramp, you want to deploy your edge clusters. We could do a whole separate tech talk on edge clusters and the design topology of edge clusters. So I'm going to just kind of keep it simple here, but just keep in mind that with these edge clusters, we do support a number of different configurations in terms of you can deploy an edge cluster that's set up for the ARIA suite. You can deploy one set for Kubernetes. You can deploy one that's just the basics, and you're going to go in and customize it yourself. So a little bit of flexibility there. Okay. And here's our last section. We're going to jump into storage, and I'm going to talk a little bit about storage, and then I'll go through the last little bit of Q&A, and we'll wrap up as our time is coming up. So storage is one of the it's a very common topic, and it's one of the areas where a lot of questions typically come up because, like I say, we do recognize that there's not a one storage fits all a solution, and that many people have different types of storage, and those different storage solutions work great for them. They want to continue to use them. They have significant investment in them, and you can continue to use those with Cloud Foundation. They are supported. With a couple of exceptions that we'll talk about. So in terms of vSAN, so vSAN is required, and it's required for that management domain. So that first management domain that you create has to be a vSAN ready node. Okay, you can choose between vSAN architectures. There's the newer ESA architecture, which is based on NVMe, and then there's the older OSA architecture that is out there. So, but you can support either. But vSAN is required, but that's the only place it's required. Within each workload domain, we have this concept of principal storage and supplemental storage. So principal storage is basically, if you ask the SDDC manager what type of storage is being used within a workload domain, that is going to be the principal storage. So it's the primary storage type that's used for that workload domain. Supplemental storage is, hey, have you added any additional storage to that workload domain? So like say I go in, I create a workload domain with my vSAN as my principal, I can still mount NFS data stores. I can still present fiber channel LUNs, and I can access those as supplemental storage. It's just that when I go in and I do something like an expand cluster or create a cluster, the SDDC manager is going to know about the principal storage, but it may not know about the supplemental storage. So if I go in and I expand this cluster, it will make the vSAN data store bigger, but I may have to go to those new nodes and mount the NFS data store that's on those because those were supplemental. Okay, so that's the idea of principal and supplemental. As far as principal storage goes, we got support for vSAN, vVols, NFS, and Fiber Channel. And again, I just call out that noted limitation. We don't yet have iSCSI there. So when you create a workload domain, one of the first questions we'll ask you is, what kind of storage are you using with this workload domain? Or you create a cluster, what kind of storage are you using for this cluster? And these are the options you can choose from: vSAN, vVols, NFS, or Fiber Channel. Once you've deployed those clusters and you want to add additional clusters, you can add whatever type is supported by vSphere. So iSCSI, vSAN, vVols, NFS, Fiber Channel, NVMe. So supplemental is whatever. So typically, you know, supplemental storage is stuff like, okay, I have a cluster, I got my primary storage, but I want to basically put an NFS volume where I can just put a bunch of templates or something like that. So again, just kind of reiterating here, just to make sure we're clear. vSAN is required for that first workload domain. All clusters in the management domain have to be vSAN. That is part of the current architecture today. So if you ask me the question, is vSAN required to deploy Cloud Foundation? The answer is yes. However, it is just limited to that first management domain, those first 4 hosts. Additional workload domains, additional clusters can be a choice of vSAN, vVols, NFS, or Fiber Channel. And then once you stood up those workload domains, you can always add as supplemental storage any of the vSphere supported storage options. Okay. In terms of when you deploy things, the type of storage you use can impact some of the operations that you do. So for vSAN, of course, because it's used for the management domain, you can standardize and use vSAN across the board. vSAN has storage policy space management. The thing I would call out here is, well, I think that's pretty self-explanatory. Let me just go to the next one. And there are some differences in terms of how many servers are required. So for example, if I want to go in and create a remote cluster with vSAN, I need 3 nodes. If I want to create a cluster for hosting Kubernetes workloads, I need 3 nodes. You'll see here that for the management domain, the minimum number of hosts is 4. And then for all the other types, it's 3. Well, if I use NFS and Fiber Channel, you can see where sometimes I can get away with just 2 hosts. So if I'm using NFS, I can do a 2-host cluster. If I'm using NFS or Fiber Channel, I could do a 2-host remote cluster. Note that for the Kubernetes offering, though, the number is still 3. That's because we have, when you create a supervisor cluster, there's going to be 3 control plane VMs, and we need to have 3 servers to run those, so they run on separate hosts. Okay, we're out of time. Let me just go through some questions here and see if I can answer them. So we already talked about the configuration maximums in terms of 25 max workload domains. That's the 1 management domain plus the 24 VI domains. And then the enhanced link mode is limited to 15. That's the management domain plus 14. So we got that. There's a link to a technical deep dive playlist. So the YouTube channel there, youtube.com, just search for VMware Cloud Foundation. I have a Getting Started series I'm working on. We have a number of videos. We are actively working to add more, so do check back that as you see fit. And it's asking about the disaster recovery requirements for VCF. Should we purchase more than one for DR and SRM and with the add-ons? Yes, if you have a requirement for high availability disaster recovery, BCDR, you'll need to have 2 separate instances, one running at the primary site, one running at the recovery site. That recovery site can be public cloud. It can be another data center. You get into that dual region topology that we talked about. If you get into our VMware validated solutions, the way we deploy the ARIA suite is based on a 2 data center with failover using vSphere replication plus SRM. And we also have, as part of the vSphere lifecycle recovery, the new DR capabilities in there. So yes, for a recovery, you'll want to have at least 2 separate sites, and they'll need to be licensed separately. And then for the latest M7i, the storage, no storage is given. So this is talking about VMware Cloud on AWS. So with VMware Cloud on AWS, it's a little bit different of because you're using AWS, the automation is a little bit different. So you wouldn't have the SDDC manager, you don't have the cloud builder. You go to the AWS portal and the VMware Cloud portal, and you would use it. And behind the scenes, they use a similar type of automation to stand it up for you. So if you have 2 VCF instances across 2 regions, you do not need to use NSX Federation. NSX Federation just allows you to basically federate security policy storage, security policies that you've set up across different NSX fabrics. There's not a requirement for NSX Federation. While NSX Federation can provide some benefits in terms of making sure that my distributed firewall policies at the primary site are also available at the DR sites. When I fail over into an environment that's just as secure. So there are some benefits to doing that, but it's not required. Okay. And looks like so we're out of time. I didn't get into lifecycle management. If people want to stick with me for another 5 minutes, I can just kind of give you just a quick 2 cents on lifecycle management. So once you stood up your private cloud, I used to work vSphere, and one of the things that always surprised me that I always, when I would talk to people, I go to like to VMworlds or VM Explorers, and I'd get in these rooms with 800 people. I'd always ask, how many of you are running versions of vSphere that are more than 2 years old? And inevitably, 99% of the hands go up. And then I'd follow that with say, how many of you want to run versions of vSphere more than 2 years old? And all the hands would go down. And so the question then became, if you don't want to run old, out-of-date versions, why do you do it? And the answer was always inevitably the complexity associated with it. And when you go from a vSphere solution to a vSphere plus vSAN plus NSX solution, the complexity associated with that goes up even further. So here you have an example of we have updates. These updates come out over time, and different components will update different points. So part of your job as an administrator was to go in and to track these updates, to understand their dependencies, and to basically go look at spreadsheets and come up and figure out what is the installation order. How do I make sure I don't upgrade vCenter and break NSX or vice versa? There's a lot of complexity with that. That complexity basically equated to the fact that upgrades were something that scared us. We didn't do it. We stayed away from them. So with Cloud Foundation, one of the main goals we had was we wanted to simplify this process. So what we do is we mask all that complexity behind the SDDC manager. So what we do is with the SDDC manager is we basically are aware of the architecture, again, that prescriptive architecture. We know what versions you're running based on the bill of materials. And we go in and we say, okay, we're going to treat this as a unified solution. And when we have updates, we release these updates as bundles. So the update bundles will show up in the SDDC manager. You'll get a notification saying, hey, there's an update available. You can then go in, review it. You can look at the metadata. You can see, is this an SDDC manager? Is this an NSX update, a vCenter update? What is this update? You can review it, look at the details, and then you can figure out, okay, I want to apply this. Before I apply it, I go in, I run a pre-check. The pre-check will go in, look at the domain, look at the health of the domain, look at the health of all the components, the ESXi, the vCenter, the vSAN, the NSX, make sure there's no alerts or alarms, basically make sure we're in a good, healthy state. And then we can go in and schedule the update, at which time it will apply the update. And we use the SDC manager and the automation of the SDC manager to apply the update, and it will orchestrate and guide you through this. You never have to worry about, is it going to install in the right order, because the SDC manager is going to dictate that order based on these update bundles and metadata associated with those. And then once we update it, we can go in and monitor it. We can make sure it's completely successful, and it's just kind of this cycle. So as we go from VCF 5.1 to 5.1.1 to 5.2 to whatever the future version is, it's a fully automated update process done through these update bundles. Okay. And so with that, with 5.1, you'll get in a situation where you have many workload domains, and you won't be able to update everything at once, one fell swoop. So what you can do is we can have kind of a mixed BOM where you basically can have some workload domains running at 5.0, others running at 5.1. But the updates is done on a workload domain by workload domain basis. Okay. And so I think that wraps us up. Let me just kind of jump to the end of the presentation here. This is just talking about password management, certificate management. It's also done. These are all the automation. But what I wanted to get to is this slide here where we talked about that holodeck. Here on the right, you can see an example of just, you can go out to hands-on labs. We also have something called VCS Experience Day. If you can get access, talk to your sales teams, get access to that. This is where you can basically get into it's almost like an expert-led workshop. You get in, you have experts who will sit there, give you access to an environment, and let you go through and spend, 8 to 10 hours just going through different labs and different exercises. And on the holodeck, if you have a server and you want to build a lab yourself and you want to do the nested like I was showing, that's where you can go. And here's some links for more information. All right, so I see one last question here. So for you guys who are sticking with this, I'll go ahead and take it. How about support with vSAN ESA with VCF? Does it need a mix of support brownfield, greenfield with OSA? So we do support ESA. with Cloud Foundation. When you deploy Cloud Foundation, it'll actually default to ESA. You'll have to deselect ESA if you want to still do OSA. In terms of that migration, in terms of going from an existing environment with OSA to ESA, we don't yet have the tools to do the in-place migration. Those are something that you can look forward to in future versions. But right now, if you wanted to go from an OSA to ESA, what you could do is stand up a new cluster in parallel and use vMotion to migrate those workloads over and then shut down that old cluster. So trying to do a migration upgrade. In terms of where we're at and what the plans are for basically being able to do an encapsulation of an existing, I'm not really sure on that. But so it looks like somebody just tested holodeck with 5.1 and 5.1 works great. Thank you. I'm glad you had success. Like I said, I use holodeck on a daily basis, all my demos. So it's good to see you're having success with that. So thanks for that feedback. Can we upgrade from 4x to 5x, which with custom VDS since NSX isn't supported? Well, you can upgrade from VCF 4x to 5x. We actually have support for skip level upgrades. So if you're on VCF 4.1, you can go right to 5.0. You don't need to go to 4.2 and 4.3. You don't need to iterate through those iteration versions. The fully supported, yes, you can upgrade from 4x to 5.0. And again, just follow that SDC manager, let it orchestrate and guide you through that process. All right, that's all the questions. Thank you very much for your time. And I know this is a lot of information. Hopefully you found this beneficial. I know you're taking time out of your evening. So again, I just want to really express my appreciation for you taking your time out, for sticking with this. And I hope you found this helpful.
Hey, Kyle, this was really great, bundling everything in 1 hour. It is really great. You covered almost all the aspects of VCF. Having said that, we cannot train anyone on VCF in 1 hour. But as you said, we will be having more session probably with you, probably some other guys, and that will drive the more agenda. But this was perfect for setting the base. And just to add to the audience, you can go through this recording once we upload on the YouTube. Some of the things that, I have personally felt, work with a lot of VCF implementation, and even the already brownfield implementation, what I see, a lot of operation guys know how to add host, how to add cluster, but they don't know the design part, which you have covered today. So for the audience, if you missed or think that this was not very deep dive, go through it again, because how many learns to use, what will be the NSXS component, all those things. This is setting up the base for the design. And we will be covering that in detail probably later, and we can invite Kyle again.
All right, happy to join anytime.
All right, let me stop the recording first.